Hello everyone. Today we're going to be looking at section 3.4, the composition of functions. When we compose functions, we're basically combining functions in several ways. The first way we're going to look at combining functions, or the first few ways, is by adding, subtracting, multiplying, and dividing. So if I'm adding two functions, say function f and function g of x, are both in variable x, then I'm taking my function of x, function of f, and I'm adding it to my g function. Same thing works the same way when I'm subtracting. I'm going to take my f function and I'm going to subtract my g function. Okay. If I'm multiplying, I'm just going to do it the same way. It's my f function times my g function. And then with the division, f over g, whatever's on top goes on top, so it's my f function divided by my g function. Okay, so let's look at example 1. And this is for functions. So we have f of x equals x minus 7, and g of x equals 3x plus 2. If I want to add my functions, f plus g of x, then I'm going to take my f function, add it to my g function. Just simple as saying x minus 7 plus 3x plus 2. Then we're going to combine like terms. We have an x and a 3x. There's always the understood 1 there, which makes that 4x minus 7 plus 2. Negative 7 plus 2 gives me a negative 5. And then that's my f plus g of x. Same thing if I want to subtract. I'm just basically subtracting the two expressions, or the two functions. So it's f of x minus g of x. So I'm doing x minus 7, and since it's subtraction, I'm going to put them in parentheses, minus 3x plus 2. This minus also works just like it was a negative 1, and I'm going to distribute that negative 1 to both terms. So I have x minus 7, negative 1 times 3 gives me a minus 3x, negative 1 times a positive 2 gives me a minus 2. Then I'm going to combine my like terms. Positive x, negative 3x equals negative 2x, negative 7, negative 2, so negative 7 minus 2 is negative 9. So that's my subtraction. Now if I wanted to multiply the f times the g of x, it's just the f of x times the g of x. So I'm going to have x minus 7 times 3x plus 2, and then I'm going to FOIL, just like I would if I was multiplying any other binomials. So I'm going to take the first, x times 3x gives me 3x squared. My outside, x times 2 gives me 2x. My inside, negative 7 times 3 gives me negative 21x. And my last, negative 7 times 2 is negative 14. Combine my like terms, so I still have the 3x squared. Positive 2 minus 21 leaves me with a 19x minus 14. So this is for my f times g of x. And then to divide the f and the g. So it's f of x over g of x. f of x is x minus 7. G of x is 3x plus 2. Since I can't factor them, sorry, didn't realize I was off the screen. Since I can't factor them, they're not the same, I can't cancel anything. You have to cancel the whole binomial in order to cancel anything. So for my composition of f divided by g of x, x minus 7 over 3x plus 2 is my final answer. Okay. If we want to make a composite function, you're putting one function into the other function for x. So let's use the same two functions. The f of x equals x minus 7 and the g of x equals 3x minus 5. And we're going to put them together. We're going to do f of g of x. That's my composite. So I'm putting my g function into my f function for every x. It's in my f function. So my f function is x minus 7. So in place of the x, I'm putting the 3x minus 5. So I'm going to have 3x minus 5. And then I've got to tag on my minus 7. This right here is my g function. And I put it into my f function. So I'm going to combine like terms. There's not any other x's, so I have 3x. Negative 5 minus 7 is 12. Oh, I wrote the wrong function now. Alright, anyway, it still works. So my composite of f of g of x is 3x minus 12. Right. We can also go the other way. We can put the f into the g as g of f of x. Still using the same two functions. So my f of x is going to go into my g of x. So if you remember, my g of x is 3x minus 5. So I'm going to have 3, and then in place of that x, I'm putting x minus 7, which is my f function, and then my minus 5. So this right here is my f of x function. Distribute the 3, I get 3x minus 21 minus 5. Combine my like terms, minus 21 minus 5 is minus 26. So my g of f of x is 3x minus 26. Let's look at, I didn't number that function a while ago, the composite function. This should have been example 2. So let's look at example 3. We're using two different functions. If I have f of x equals a negative x minus 3 and g of x equals x cubed plus x squared. And the first thing I want to find is the composite f of g of x. So I want to do my f, I'm going to put my g into my f. So I've got a negative in place of this x. I'm going to put the x cubed plus x squared, and then my minus 3 that's left for my f function. I'm going to take this negative, treat it like a negative 1, and distribute it. So I have negative x cubed minus x squared minus 3. That's as simplified as it gets. So that is my composite of f of g of x. Now let's turn it around and let's do the other way. The g of f of x. So I'm taking this time my f function and putting it into my g function. I'm going to go the other way. So my g function starts out with an x cubed. So in place of the x, I'm going to put negative x minus 3 cubed plus, and then I've got another x, and I'm going to put the negative x minus 3 and squared here. So I'm just replacing both x's with the f of x function. And then since these are cubed and squared, we're not taking it any further. So our answer is negative x minus 3 cubed plus negative x minus 3 squared. We could multiply them all out, combine all x terms, but that's just a lot of work, and I really don't want to do a lot of work. Not when all I'm teaching is, all I'm wanting you to know is what the composite is. So let's look at example 4. Again, we have two new functions. F of x equals x minus 3 over 4, and g of x is x cubed minus 1. So we're going to look at the composite, f of g of x. So I'm putting my g into my x. So my f of x is a fraction. And go ahead and start it and put the 4 on bottom. My x is first, so I'm going to replace it with my g, the x cubed minus 1. Then I got to go back over here and get my minus 3 from my f function. So I'm going to have x cubed, negative 1 minus 3 is negative 4 over 4. I can't cancel just the 4's because it's like canceling parts. I can only cancel the whole. It has to be a binomial, cancels a binomial. So my composite of f of g of x is x cubed minus 4 over 4. Now once again, let's go the other way. The g of f of x. So this time I'm putting my f function into my g function. Remember, my g function is x cubed minus 1. So I'm going to put my x minus 3 over 4, which is my f function, in for x. X was cubed minus 1. Then I'm going to simplify it a little more. If the cube is on top or outside, it goes both to top and bottom. So I can have x minus 3 cubed over 4 cubed minus 1. And then I'm going to go ahead and leave it as x minus 3 cubed. 4 cubed is 4 times 4 is 16 times 4 is 64 minus 1. If I make that a fraction, I get a common denominator. I'm going to multiply this by 64 on top and bottom. So I get x minus 3 cubed minus 64 all over 64. Alright, so the answer for the composite of g of f of x is the x minus 3 cubed minus the 64, because I multiplied top and bottom by 64 over here, and then I put it over 64. That way I have just one fraction. Right, I want to do a couple more examples and then I will be done. I know these videos are getting long, but there's several different types and I want you to have an example of each one. So this is example 5, and this time my function is the square root of x plus 4, and g of x is x minus 2 over 3. So first I'm going to do the f of g of x, which means that I'm putting my g function into my f function. So my f function starts out with a square root. So I have x minus 2 over 3 that I put in for this x, and then plus the 4 to finish out my f function. So again, I want to get a common denominator, so I'm going to put the 4 over 1. So my common denominator is going to have to be 3. So if I multiply by 3 here and by 3 here, I'm going to get x minus 2 over 3 plus 4 times 3 is 12 over 3. Once I have the same denominator, I can write it as one fraction, x minus 2 plus 12 over 3, and I still have to simplify it. So I'm going to have the square root of x minus 2 plus 12 gives me plus 10 over 3. And so this is my composition of f of x, or f of g of x. And let's look at that going the other way, the g of f of x. So I'm putting the f in for the g, or into the g. So I start out my g is x minus 2 over 3, so I'm going to go ahead and put the 3 down. And then for x, I'm putting the square root of x plus 4. Then outside the square root, I got to finish off my g function, so I'm going to put minus 2. I can't combine any terms because this 4 is under the square root, this one's outside the square root. So my answer for the composite of g of f of x is the square root of x plus 4 minus the 2 all over 3. So that's example number 5. Then let's look at example number 6. I have f of x equals x plus 1 over 5, and g of x equals 1 over x. So again, I'm going to start with the f of g of x. So I'm putting g into x, or g into f rather. So f has the denominator of 5. So I'm putting 1 over x in for my x plus 1. And I want to look at just the top only for right now, because I got to write that as one fraction. So 1 over x plus 1, so I put it over 1. My common denominator is going to be 1x, so multiply that side by x. So I end up with 1 plus x all over x. So then I can have now 1 plus x all over x over 5. That's the same thing as saying 1 plus x over x divided by 5. Now if I put 5 over 1, now I have a fraction divided by a fraction. I'm going to do the KFC, keep, flip, change. So I keep the first term, 1 plus x over x, change the division to multiplication, and flip the last term to 1 over 5. And then 1 plus x times 1 is 1 plus x. X times 5 is 5x. So my composite for f of g of x is 1 plus x over 5. Now, if I go the other way, if I do g of f of x, I'm putting the f function into the g function. So the g is 1 over x, so it's 1 over x plus 1 over 5. Now this is already in one fraction, so I can rewrite it as 1 divided by x plus 1 over 5. I can do the keep, flip, change, because I can make this a fraction by putting it over 1. So I have 1 over 1 times 5 over x plus 1, keep, flip, change. 1 times 5 is 5. 1 times x plus 1 is x plus 1. So the composite of g of f of x is 5 over x plus 1. Okay, and that's it for composites. I'll post a homework eventually with this. If you have any questions, be sure to email me, text me, or message me through Canvas.